Hello everyone, I'm Yogesh, and today in this episode we shall be extending our discussion over a very familiar concept that we encounter in our day-to-day life. We shall be dealing with the motion, the laws behind it. Why is everything around us moving? What is the sole cause of the motion of a body? Why does the ball stop at all? Well, if you remember, in our previous episodes we discussed about some of the very historic backgrounds, that is how Aristotle was the first one who observed certain things. He gave his fallacy that proved out to be wrong, but that gave Galileo an insight to look into the things. And then the Galileo's experiment and how he defined the inertia, the property or the state of a body to be in the state of rest, and how Galileo said that the state of rest and the state of uniform motion is the same. Today in this lecture we shall be extending this discussion furthermore. We shall be discussing what are the Newton's basic laws that made the motion around us so easy yet beautiful. Now we are going to discuss the Newton's law of motion, and before proceeding let us follow a step-by-step method to know each and every term that we will encounter in the three laws of motion. The first term that we saw in the Galileo's thought was that the inertia. Well, actually a lot of people think that inertia is something like a body is at rest. Well, that is not the case. If we define inertia with some sort of scientific definition, then it is that if suppose if the body is somewhere, it is say somewhere on the book table or on the floor, so what will happen that everything that is kept in a state of rest will try to remain in a state of rest only. Or if I am rolling a ball, okay, and the ball is moving, so the ball will always try to move further and further and further without any obstruction. So by these examples I can only say that that inertia is not a property. Actually it is the ability of a body to be out of some disturbance, or in other words the body's nature to remain in the state of rest or then remain in the state of uniform motion before application of some certain force is the inertia of a body. Now if I move further and I come to the first law of motion given by Newton, the statement states that everything in this universe tends to have a state of inertia. That is, everything that is kept like some idle thing on a book table or like some ball on the floor, it will try to remain there only. They don't want to get disturbed like this. No, I don't want to get disturbed, let me have a good sleep. Or if you are rolling a ball, it will say, okay, see, I am really tired of being stopped again and again and again, let me move. So this was the first law of Newton, which states that if a body is moving, it will keep on moving, or if it is at rest, it will remain at rest. But there is a very useful and a very good statement that has to be added here: until and unless an external force is applied. That is, if a body is at rest, if I don't apply some external force, like I am just sliding the book will stay at rest forever. Or if a ball is moving, if the frictional force is not there to stop the ball will keep on moving and moving and moving. So the statement is quite clear and compact and beautiful, that is, everything in this universe tries to be in the state of inertia provided no external force acts over it. Now after discussing the first law of motion, I would like to head towards the second law. But wait here, we have to know a very important term, that is the soul of the second law, and that term is momentum. Actually, momentum is nothing but, if I go for the mathematical formula, it is something like P equal to mv. Quite simple. But we are going to study physics, so we should take a deep insight of it. Actually, momentum is that, suppose I have got a body and that body is moving with some velocity. For example, I am running. When I am running with certain velocity, my mass and my velocity will have some sort of impact against any other body that will come in contact with me. For example, if I am running and my friend comes in between my course of running or the track on which I am running, I will surely hit him. So what will happen is that once I hit him, there will be some change in my momentum, and that's why a lot of times what happens is that if I get obstructed by something, my pace will change. Actually, it's not the pace, since the mass is also moving with you, so the momentum changes. Keeping this thing in mind, Newton said that whatever the force that is being applied on a body, that is solely dependent upon the rate of change of momentum. Actually, why I am emphasizing this thing, that rate of change of momentum, is basically because the example I gave you, that is when I am running without any obstruction, my momentum is say m into v. But when I get distracted by someone, or when I am obstructed by someone, I get collided with someone, my rate of change of momentum, that is my momentum, will change over that period of time. So Newton said that if I got some body and if I am applying some force over it, so what will happen is that in that course of time, the force will be proportional to the rate of change of momentum, or in a simpler words, whatever the momentum changes will be the force. So if I go further and I will say, okay, if I go for the differentiation, it is d dt of mv, and since mass is always a constant, I keep it outside and I get dv by dt. So what is the derivative of velocity with respect to time? Yeah, exactly, that is the acceleration. But here is a catch. A lot of people think that the second law of motion is only F equal to ma. I am really very sorry to tell you this, but it is not the case always. It is only a special case when F is always equal to ma. Means it is a special case while handling it, but the general case is that the rate of change of momentum is the force acquired or the force imparted over that body. Now, after discussing the two laws of motion, that is the law of inertia and the rate of change of momentum, Newton said that whenever a system is there, for example, if there are two bodies in the system, so the force that is means the first body is experiencing because of the second body is exactly equal to the force that the other body is experiencing due to the first one. I think you must have been remembering that law, that is the Coulomb law. In Coulomb's law, what we saw that there are two charges. So one charge is imparting some force over the other, and the other one is also replying back with the same. So this is the third law of motion, that is for every action there is equal and opposite reaction. It sounds to be really very simple, but there are a lot of misconceptions that are always there in people's mind, because they think that law of action and reaction is something like that, if I do some action, I will get some reaction. And then they will say, Yogesh, I totally agree with you. That is, if I have some action, I will get some reaction. What if I kick, or sorry, that's called punch. What if I punch a wall? Means, or what if I punch a tree? The tree is not moving at all, or the wall is not moving at all. So I think the third law of motion fails here. Well, I'm really very sorry, but that's not the case. Two things we must consider always. Whenever the bodies are of comparable size, then only you can see some changes. Can you expect your this fist to move a wall, actually the wall is moving, but can you expect your this fist to have that much impact that you can see? And the second thing a lot of people don't get it is that once you are hitting the wall, so there is some particular layer over the wall, maybe it's of paint or anything, and if you clearly observe it, your force that you are imparting with your fist is displacing some of the material over it. Like if I have got this and if I impart the force with my fist, what will happen is that the upper layer of the wall is a bit removed or it's a bit turned, and also I also get hurt here. So what is this? I imparted some motion, because due to my motion I imparted some force over it. The upper layer got disturbed and I got hurt. Well, exactly this is the case where the third law is applicable. If I am really a He-Man or if I am a Superman sort of guy, and if I will simply punch the wall, I can make a hole in the wall because my force is that much greater. So this we all should remember that the third law of motion is valid everywhere in this universe. Also, one more point is that a lot of people think that when I do some action, after some time I get some reaction. Well, this is not the case. Action and reaction always occurs in pairs. Means the moment you have done an action, you get a reaction. That is so instantaneous. Otherwise, our life could have been really horrible. Just imagine if you have done some action and you get some reaction after 5 minutes or 10 minutes or 15 minutes, you are gone. Okay, suppose you have got a bread and you put that bread in a toaster. So the toaster will start heating it, okay, and the instantaneous moment it will start heating. Suppose if it is not working and you put the bread into the toaster, you switch on the appliance, it is not heating. You are really frustrated. You say, no, it's not working. So this is what the case with the third law of motion. This is not practically the law of motion, third law of motion, but it is some sort of analogy. The electrical energy in the form of heat is imparted to the bread, and the bread gets burnt or gets some sort of fried or something thing. So they act instantaneously, that we must always take into consideration. Now, after discussing all the three laws, we will sum up by taking a very simple example. Suppose you are traveling in a car and a bug is coming or a mosquito is coming. Then the mosquito will hit the windshield of your car. Okay, so what will happen is that the mosquito will ultimately die and you are all safe. You say, I am stronger. Well, actually the three laws that you can get from this incident is as follows. The mosquito was moving with some certain velocity, and if I go for the first law, it was having some sort of inertia. It was moving with some speed, some state of before the application of some force. So when it is moving and you simply hit him, there is a change in inertia, and with that change in inertia there is a change in the force that is applied. Means there is a new force acting over it. So the rate of change of momentum, that changed. And if you say that the third law is not applicable here, then this is only the case that we discussed, me punching a wall. So the state of inertia of the mosquito was disturbed, the rate of change of momentum was observed, and since one more thing, since the time lag was really very different, it was some few microseconds, the mosquito was not able to bear it, and so he collapsed or he died. So that is, the lesser the time, larger the change in momentum, larger is the force. That's why your car and you survived, but the mosquito died. And the third law, the mosquito also had some force over you or your wall on you, that particular windshield of your car, but his size was really very less as compared to the size of your car. So that's why you didn't notice any change except that you had a dark spot over there. Thank you.